Afternoon, everybody. Thank you for joining us on today's Adding Value program. We've got a really busy schedule ahead of us this afternoon. So we've got some great presenters from across the automation industry. We're really lucky to be so well attended, and we're really lucky with some of the people that we have actually presenting for us today. So we're going to hear about some new products, we're going to hear about some new software, some innovations in terms of technology. Each of the presentations is going to be kept to about 20 minutes long, and then we're going to have time after each presentation as well for some questions and answers. So anybody with any questions, please put them into the Q&A section, and then what we'll do is we'll pick them up at the end of each presentation as well. So yes, thank you very much. That's brilliant. Next, we have Daniel Banks coming on to present on a new clean energy VSD from Siemens. So, are you there, Dan?
Yeah. Hopefully you can see and hear me all right.
Yes, perfect. Thank you.
Right,
so yeah, over to you if you're ready.
Yeah, no worries. Let me see if I can manage this sharing malarkey. Just going to get my screen shared for you. No problem. Then we'll press on.
There we go. Yeah, perfect.
Yep, excellent. Right, okay. Hi everybody. So my name's Dan Banks. I work for Siemens in the drives part of the business here in the UK, and I've been working in the drives industry for 24 years, I think now, pretty much constantly. And today I would like to take the opportunity just to talk to you a little bit about harmonics, one of my favourite subjects. Tell you a bit about what they are, make sure we all have an idea of what they are, why we care about them, and then introduce this new G220 clean power drive and talk to you about what it does, why it's different, and hopefully why we're all going to be paying a bit of attention to it. So what's the challenge with harmonics? We've got this growing demand in the world for energy and energy efficiency and for power supplies to be clean. And this is particularly prevalent, I would say, in the UK, but it's a global challenge. Industries facing challenges in terms of meeting new grid regulations, grid compliance, and distortion levels generally are rising across our power supply networks and systems. And that's for a number of good reasons, essentially, which we'll talk about in a bit. So obviously, to address these sorts of challenges, we all need solutions that keep our power supplies clean, minimize our harmonics, keep our equipment nice and healthy. And that's what we're really going to talk about today. And I will share the slides afterwards. There's quite a few links in here to reference material and documentation, which you won't be able to get by watching the video. But of course, if I share the slides after, those links should be nice and functional for you. So first of all, what are line harmonics? So a real basic take on this is a standard AC power supply out in the world is going to be operating at a sine wave of typically 50 or 60 hertz. So, you know, a nice, neat, perfect picture like we've got in that blue box on the bottom left-hand side there. And non-linear loads, so power electronics devices, including drives, tend to distort them. They'll cause variation in voltage and current from that sine wave, and we call those distortions harmonics. And actually, that picture on the bottom right-hand side there is a pretty good indicator of some of the sorts of distortion types you might see from a variable speed drive. So I think there's a couple of things we want to unpack in that subject and just make sure we've got our head around. So first of all, what are harmonics? One of the real common things I found during my time in this industry is that harmonics and EMC or RFI, I guess, get mixed up. So let's just clarify what we're talking about there. So harmonics that we're talking about today, line harmonics, these are low frequency disturbances, but they tend to be high power relative to the load. So we're normally looking at up to the 50th, or even in the UK these days, typically the 100th harmonic. So That's from 2 times the base frequency, so 50 hertz in the UK, up to 100 times, so up to 5 kilohertz. And as I say, that is typically high power relative to the load you're generating, or you're consuming, I should say. EMC, we talk about, EMC means electromagnetic compatibility, and actually what we're really talking about there is radio frequency interference, or EMI, electromagnetic interference. And the clue's in the name there with RFI. This is radio frequency noise. So we're talking 150 kilohertz up, way up into the megahertz and gigahertz even. And this kind of noise is typically generated by anything that's doing high frequency switching, so microprocessors, any kind of chips, anything like that. And it's typically very low power relative to the consumed power of the device. Two very different sets of phenomena that we meet when we're talking about electronics, and in my opinion, with two very different sets of challenges and outcomes. So EMC, RFI, is typically seen actually as a health and safety issue. And you'll find it's baked into CE marking and the machinery regulations, and broadly covered by safety regulators in the UK. And that's because interference of this kind of noise that could cause unsafe operations. So the example I tend to always give, and many of you might have heard me say this before, is when you look at the product standards that you need to meet to CE mark a product, about the amount of radio noise you can emit through space, you'll find one particular frequency where the level is very, very low, much lower than all the surrounding frequencies. And you might look at that graph and think, why am I not allowed to generate noise at that frequency? Well, that frequency is the search and rescue beacon frequency. And as you can imagine, you do not want blanket noise at the search and rescue beacon frequency. If you turn your TV on and a helicopter lands on your front lawn, that's an issue. But it's a health and safety issue, because actually, if Flight Lieutenant Jane Doe crashes her jet plane in your front lawn and pops her SAR beacon, you really want a helicopter to come and land on your front lawn. And if your TVs were outputting blanket noise and drowning out her signal, that's not going to happen. So that's the world of EMC, and that's not what we're talking about today. Harmonics generate us a whole different set of challenges, and they're often associated with interference, but in my opinion, that's broadly a 20-year-old view. Back in the day when we had filament bulbs and CRT TVs, harmonics could regularly be seen causing interference. And when Mr. Jones at the end of the road used to complain that his lights flickered when they turned the pumping station on at the water company, that would be harmonics. That's low frequency, causing visible fluctuations in visible electronics. But actually, unless harmonics distortion gets really, really high, it's pretty unlikely in this day and age to actually cause any kind of interference like that. I'm not going to rule it out, but it's not common, I would say. So these are the sorts of standards that the world has defined for us. There's a couple of IEC standards, there's a couple of IEEE standards that refer to harmonics, both for product standards and for grids. But actually, in the UK, we tend to worry more about a standard called G55, formerly G54, which is a standard rather than a regulation. So it's not the law. No one's going to sue you if you don't comply with it, or the government isn't going to sue you at least. But typically there'll be some clause in your contract with your power supply company that says that you will make sure that your site is compliant with this standard. And what it, waving my finger in the air, says is that the harmonic distortion on your network at the point of common coupling, so where you hit the public grid, won't go above about 5%, usually 6%, something like that. It's quite a long, complex standard. There's loads in there to read about, but essentially there are a number of outcomes that you could get if you don't comply with that standard. And they could range anything from maybe your power company is actually measuring your distortion and it fines you for being over the limit. Maybe you're actually paying based on your power factor. And if you're paying based on your true power factor rather than your reactive power factor, then harmonics are going to kick into that. And I have dealt with companies whose punishment clause, for want of a better word, if they weren't compliant with G55, is the network could turn their power supply off. That's not a good look. Nobody wants that. So this is why one reason why it's quite important. The other reason is what those line harmonics do. So I mentioned non-linear loads earlier, and this is why this is becoming a much bigger issue in this day and age. Non-linear loads is really anything that doesn't draw power smoothly. So a VSD is a non-linear load in the sense that a standard 6-pulse drive pulls chunks of current as and when the diodes open. But almost everything is a non-linear load. I can look around the office room I'm working from here today, and I can see half a dozen devices that are non-linear loads. The LED light bulb above my head is cutting up AC and turning it to DC. It's a non-linear load. The power supply that's powering this monitor, my laptop, they're non-linear. They're taking AC, they're chopping it up into DC, and therefore they're non-linear loads. My phone charger, exactly the same device. So these devices are ubiquitous. They are everywhere. Almost every piece of electronics we use at home now, with the possible exception of a kettle, is a non-linear load. And that means that background noise that maybe 20 years ago, when we were still using filament bulbs and CRT TVs, has lifted up significantly. And then on top of that, we've piled renewable energy, solar power. Solar generators are all variable speed drives. Every single wind farm we see has got an inverter in it. So this background noise is lifted up, and that's why I'd say over the last sort of 5 or 6 years, harmonics has really risen to the top of the issues. And the reason for that, why we as consumers or operators of industrial equipment care, is because what it's doing to your equipment. Yes, it's nice that there are all these standards and we've signed some contracts, but actually, what is it doing to our equipment? And the long story short version is it's aging it. These harmonic currents that come from these non-linear loads and drives are always seen as the big culprit, because harmonics are proportional to the power you consume. My LED light bulb above my head is 7 watts. The variable speed drive in the pumping station down the road that pumps the water into my house is probably 22 kilowatts. So we're talking 2 orders of magnitude higher. That current circulates to your circuit. So as you can see in this diagram here, once you've got that distorted current circulating, it's not doing any work, may not be costing you any money if you're not measuring it, but it's absolutely heating up your circuit breakers, your fuses, your cabling, your transformer, and potentially any other devices on the network. For example, there's an electric motor here that you can see that'll be generating extra heat. It might also be generating noise. It could be causing you nuisance trips with any thermal devices because of this extra heat, and it's messing with your true power factor. So those are the challenges that we really see in industry in the UK with relation to harmonics. And I've seen sites where they've had catastrophic failures to transformers, and they could look at their data and 100% say this was because our harmonic content was too high. So that's our challenge, and that's what we need to address. And there are typically a couple of ways of addressing that. If we go back 20, 30 years in the drives industry, it was the idea of multi-pulse converters. So you'd have a 12 pulse or an 18 pulse front end, by which I mean you take a standard drive and you parallel up the inputs. So a standard drive would be a 6 pulse. There are 2 diodes on each phase, one for positive, one for negative. Double that up, put a transformer in front of it, and you get a 12 pulse converter. Pretty tidy, actually. Cuts your harmonic distortion down probably to about a third of what it would be before. Go beyond that and go to 18, 24, 36 even. That was the way these were addressed when you needed to do high power drives. But I would say, again, my opinion, that's kind of an old world technology. And the reason primarily for that is because of this lovely picture of a Siemens transformer on here. You've got to have a transformer sat in front of your system to do that, to phase shift your supply, to turn your 3 phase into 6 phases or 9 phases or 12 phases. And you're putting those transformers in there inherently inefficient. They're eating your power, they're generating heat. They're not where we want to be, and they're also expensive. You probably need to do maintenance on them, etc., etc. I'll touch on line reactors and DC chokes. Drives are very harmonically noisy. It's the nature of the beast. I would say majority of good quality drivers you're going to buy in the UK have got line reactors or DC link chokes built into them, which significantly reduce that. Really, it's often only very small. So let's take Siemens, for example. We only sell very small inverters without chokes. So we usually offer a choke as an option. And it's if your drive is a very small part of a high power consuming machine, maybe you can get away without a choke. But typically, we're always going to have chokes in. The next step is to go to a passive filter. This is a tuned circuit. Essentially, it tunes into that frequency of noise. It cuts it out, takes it away. Not well accepted in the UK, I'd say. There are challenges with them in terms of their tendency to, because they're tuned circuits, to pick up other noise around them, soak it up, maybe get into a resonance with the circuit they're connected to, and they have a tendency to, if they're not designed correctly in the space, overheat and cause challenges. I'd say in the UK, it's much more common to see active filters. This is an example of an active filter down there. And what these devices do is they literally measure the harmonic noise and they generate the anti-phase signal. So they cancel it out and they give you that much lower effect. In fact, you could size those if you wanted to go all the way to 0. But the other solution that can be much neater in the drive world is a clean power drive, or what traditionally in industry be called active front end drives. And the benefits of using an active front end solution really is it's a simpler install, single box, cables in, cables out, happy days. No messing around with multiple devices in your panel. Often designed to give a clear compliance with a particular standard. Usually very power efficient in the way they do things. And active front end drives aren't new. They've been in the marketplace for a long, long time. Traditionally used more for power regeneration, where you want to take energy from your load and put it back into your power supply, but they're also really good for keeping your harmonics down. And this is where the G220 Clean Power comes in. So this is a new drive that we've released in the last year or so, and it's using a new kind of technology to do this. So it's very much an active front end drive, but it's not using the traditional fully rated IGBT stack that many of you might be familiar with from our product ranges and ALM or other manufacturers. It's using a different kind of technology. So again, it's giving you great power quality. It's going to give you that grid compliance. It's going to increase the resilience and reliability of your equipment. And obviously, being a Siemens bit of kit, it's going to give you a really easy integration and commissioning system as part of your automation. So let's hit some of those headline numbers and just really talk about what we're talking about here. THDI in a typical power supply system, lower than 2%. That's a big step up from, I would say, where commonly available clean power or low harmonic drives have previously been. Even our own active front end system, the S120, we would normally say THDI less than 3%. So we're knocking about half the noise out of the system with this new drive. That gives you a power factor of 1 or under almost any load condition with no reactive power at all. So that's really, really neat. Obviously, the drive comes with the compliance with all those IEC and IEEE standards we talked about. But the other thing I'd say that's really important and a big headline for this product for us is size. If you go out and compare this to the installation of a drive with a filter or even a commonly available, typically active front end drive from another manufacturer at the moment, you're going to find, because we're using this different technology, this is really, really compact. I mean, against a filter, you could say, I'll show you a picture in a minute, of maybe an 80% size reduction. And again, it's a Siemens drive. It works into that Siemens integrated world. So if you've got a Siemens automation system, it's going to be absolutely effortless to install using the TIA board system. I'm keenly aware of time, so I'll press on. Just to give you that headline again, 2%, less than 2% THDI. There's a nice picture of it there to show you what we're talking about. And again, if I move on, just to give you a comparison, the G220 drive range exists in clean power and non-clean power. So if we look at the non-clean power version, you might be looking at THDI. That's a current distortion percentage of 33%. We could fit that drive with a passive filter. That gets down to about 4%. But the clean power drive comes in 1.9% in this case. That's a measured number as well. That's not sort of calculated. We've got a real product because they exist. They're out in the world and we've measured it. So you can see it's really clean. It's really going to help you get that compliance, drop your noise levels down, bring the reliability of all your equipment up. I'm not going to go into the product in detail because I've gone a bit long, I think. There's loads more information here. I will flick through the slides so they're in the recording and I will share them. This drive is currently available. It's available as an IP20 drive and as an IP55 drive if you need to hang it on the wall. And you can see there with the IP55 variant, there is an option just to have an isolating switch on the front if you want it. It's available in what I would call a 400 volt version, so 380 to 500 volts. And it's up to 55 kilowatts right now available. By the end of the month, we should have 110 kilowatts. By the end of the year, 160 kilowatts, which covers an awful lot of the market range. Again, there's a couple of links you'll get shared afterwards there to some more documentation. And again, if you want to go do that size comparison, there are the dimensions of the products there for you to have a look at and see how we stand up. We've got 3 frame sizes in both products, one that gets you up to 22, up to 37, then up to 55. And you can see they're very, very compact indeed. And I haven't mentioned it, but as a side bonus, if you are in the water industry, these all come with a 3C3 coating across all the products, all the components in the product. So they're really going to be nice, resilient bits of kit. And IP20 to IP55, broadly the same dimensions, a few changes here or there. I'm not going to dwell on this, but suffice to say, G220 is part of our next generation of Dynamics drives. So it's really heavily integrated into the Siemens world. So if you're using a PCS7 system or a S7 based PLC system, using a TIA portal system to configure your automation system, you can just drag and drop G220 in, quick wizards to set it up, auto optimization, happy days, and away we go. So again, just to highlight that, 2% THDI, 100% output voltage at full speed, including voltage dip ride through, because it is an active front end, so it can do boosting of your input stage, input to output voltage, I should say. And that's going to reduce the losses in your surrounding system from the harmonics in there by up to 30%, which I don't think is the headline. It's really about that maintenance piece of cutting down that heat and keeping your equipment nice and reliable, and potentially reduce the losses in your motor from running a needed supply. There's a number of options available at the moment. There's a keypad built in. There's a nice touchpad, 5.5-inch. I can't believe it's not a mobile phone screen that you can mount in the front of your keypad or have handheld. There are a number of options for comms. Profilet's the default at the moment, but others are coming. You do have the option to get what we call a safe motor temperature module, so you can connect an ATEX motor with PTCs directly into the drive and maintain your ATEX compliance. And we do have this nice industrial Internet of Things connection, which is a dedicated high-speed comms network for data gathering and condition-based monitoring type work, so that you can keep your comms network for your automation system nice and secure away from the internet, and over here have a nice secure 62443 connection for going off to maybe an on-site edge monitoring system, or maybe up into the cloud for something like Siemens Insights Hub or some other cloud-based data monitoring system. Some technical blurb. I'll leave it on the screen for 20 seconds so you've got time to pause it if you want to look at it later. And again, a bunch of links to things like our online product configurator, which makes selecting the drive really easy, or the TIA selection tool, which does the same. There's an app on the phone you can use, and a bunch of links to some of the software packages, including the ability to fully simulate this drive. So you can download Drive Sim Engineer. You can essentially run this drive on your laptop without a physical drive present, program it, give it commands, see how it behaves, and really get an idea for what the drive's going to do, and does your settings work on it before the drive's even turned up, maybe. And again, a few more links for bits and bats. A closing comment, perhaps. This drive comes with a 24-month warranty as standard, and an additional year for free as long as you go ahead and register it on our website. So happy days there. Additional warranty on top of that can be offered, and training and all the things you'd expect from Siemens, I guess. And again, a big pile of links which you'll get after the material, after the presentations for all the material and stuff. I think that's me covered. Apologies, I think I probably went a few minutes long. Anybody got any questions?
That's fantastic. Thanks, Dan. That's really good. So yeah,
Hello.
very, very good
Hello.
explanation. Oh, hello.
Hi. I had a question.
Mm.
Dan, I was just wondering how easy it is going from a G120 to a G220 in terms of uploading, downloading parameters and firmware.
Yeah, so I mean, it's a really good question, and I'll hold my hands up. I think the nomenclature of the drives could be a little bit confusing. So G220 is a brand new drive. It's not the replacement for G120. It's very much sits in. I didn't want to get into G220 in detail. I wanted to talk more about the harmonics element today, but it's very much a new product that sits in a new space, kind of above G120 as a high performance product. If you know how Siemens drives work, you won't be shocked when you use it. But what I would say is it's probably the easiest drive to use, either from the keypad or from the software that I've ever used. So the SDI Pro keypad that I showed very briefly on here, the touchpad one, is really, really intuitive, really easy to use. And what it's essentially doing is it's hosting a web server. So you can also interact with the drive on a web server by using your mobile phone or a tablet or a PC. You can either connect directly via a cable, or we have a little dongle you can plug in to generate like a local Wi-Fi. And that will allow you to upload, download parameters in that regard. You can obviously use our Start Drive software, which is free to do that as well. There's an option to use memory cards and plug in and out with memory cards. So I would say if you're a G120 user, it's comparable, it's not identical, and you should find it easier. Does that answer the question? I'll take silence as yes.
Yeah, I think that you've definitely covered plenty in there, haven't you? Definitely. Is there any other questions? No, I think you've covered everything. That's genuinely done that. That's been an excellent presentation. Thank you very much.
Thanks, Dan.
So, as you said, obviously we'll be sharing the presentation slides and video recordings and any documentation people want as well. So, if you want some more info on that, Gregor, let us know and we'll get that sent over for you as well. So, thank you very much, Dan. Much appreciated.